boys and girls, we're going to look at a type of problem that involves dividing fractions. And so this math is definitely new to you. You did not divide fractions last year in fourth grade. And so this particular video, we're going to talk about one of the types of problems that you'll see, and that is dividing a unit fraction by a whole number. And so on this particular problem, let's kind of talk about what that really means. So I'm going to try to break it down and try to show a couple of things here that you need to be aware of. One, when you start the problem, you're starting with a unit fraction. So unit fractions, again, are fractions that have a 1 as the numerator. That's where it gets its name, unit. Unit means 1. And so you have 1/3 divided by 4. What I think a lot of students struggle with in fifth grade is just kind of wrapping their head around that concept and understanding what's really happening. So it's kind of different. It's kind of weird looking when you first see it, but then after you practice it for a while, it should kind of start clicking and make sense a little bit better. Now, the one thing I have on the page already is that when I teach this as what's called a leftover problem. And I think it's because when I teach it, and if I show the math behind it and we come up with an answer, a lot of times kids don't see how they get that answer, or how, like, it just doesn't really click and it doesn't make sense. Well, they're kind of thinking, okay, how in the world do I get that answer? That just doesn't make any sense to me. So I'm going to try to show it in a way where we're going to solve the problem, but you can also think about it in the form of a picture. And so that's where the word leftover comes in. So the word leftover, to me, you think about having leftovers, like you're having maybe a meal and you're eating something with your family, and there's leftovers, and those leftovers get put away and you maybe eat them another time. So here on this particular page, I have a dish here, which in my opinion, it kind of looks like brownies or maybe like a cake. And so I'm going to use this to explain how this problem would work out in the real world. Okay, so let's just say you had this picture, and it was, we'll use brownies, and we had brownies there, and you and your family were eating on them. Maybe you had like a get together and your family ate it, and after you ate it, there's only 1/3 of the brownies left. So what I'm going to do here is I'm just going to kind of use the picture, and I'm going to try my best to model what I mean by 1/3 of it left. So if I broke it into thirds, the part that I'm scratching out, this is kind of what I'm pretending like is it's eaten. It's already gone. That's what everybody came in. I always kind of joke around, and I might say this, hey, if there's only 1/3 left, then I must have been hungry that day, because 2/3, it's no longer there. And so I'm going to scratch that out, and I'm just going to represent that part being scratched out as that's what's gone. That's what's been eaten. So you're starting really with 1/3 in your pan there. And so let's just say you came back, and it was a couple of days later, and you had some buddies at your house, and you and your buddies wanted to eat the rest of the brownies. And let's just say there were 4 of you. So this problem is 1/3 divided by 4. Then what I would think about is I would take that part that's remaining, and I would then think about cutting it into fourths. And so now I'm going to draw some lines going the opposite direction, and I'm going to show that there are basically 4 pieces left. So I'm going to kind of put circles in those just to kind of represent that, okay, that's the portion that everybody's going to get. Okay, so picture yourself and your buddies sitting there, and let's just say you thought about what you're having, the piece that you're having. So I'm going to put a check mark in the piece that you're having. So I'm going to change colors here, because I think this would maybe stand out a little bit more. I'm going to switch to yellow. So on this particular problem, if I were to think about it, if I'm eating, I'll put another check mark there, if I'm eating that piece, that slice of brownie, then really I'm eating 1/12 of the original pan. And so it's kind of weird to say it that way, but if you go and you look at this picture, how it's kind of been broken down, you know, now that I look at all my lines and I kind of think about it, I'm going to use some dots here. So if I go and I put dots on what would have been pieces or slices of brownies, if you want to think of it that way, I could see it as, well, now originally there were 12 sitting there. And if I came and my group of buddies and I were eating and I split it up, that 1/3 that was left, then if you split it up and each of you had a piece, then that piece that you're eating, I'll go back to my check mark here, you're eating 1/12 of the original pan. And so it's kind of hard to see through the problem and kind of understand where you would get that answer. But that actually is going to be your answer to this problem. Our answer is going to turn out to be 1/12. So it's kind of tricky. And again, I think the more you try it, the more you see it, the more it'll make sense. But if you know fractions really well, then that should make sense. Because think about it, 1/3. If that's your leftover, is that 1/3, and then you take that 1/3 and you split it up like you did with your buddies, then you're going to get a smaller fraction. You're going to get a smaller portion than 1/3. And so 1/12 is definitely a smaller portion or a smaller fraction than 1/3. That 1/12 is a pretty small piece. And so it's kind of like, okay, well, if you had a 12th and then your buddies had a 12th and then there was 4 of you, then that ends up being, well, okay, well, if there was 4 of you, then everybody got 4/12ths. Okay, well, if all of you together got 4/12ths, if you think about that fraction, 4/12ths, that could be simplified down to 1/3, and that's what y'all had to begin with. So I think that's what's tricky is it's hard to wrap your brain around starting, your problem off with a fraction. You guys have always thought about starting a division problem off with a whole number. Well, now you're starting it off with a fraction, so that's kind of weird. So I'm going to now show, and I'm going to keep the yellow here on my color, I'm going to now show how to solve this using an algorithm. Now this is actually pretty easy. I think most students pick up on this pretty easily, but it is kind of tricky at first. There's a couple of things that you got to make sure that you do correctly. So I'm going to rewrite the problem. The problem is 1/3 divided by 4. Okay, so what you do on these problems is you always you think about a couple of things as you work them. One, it's kind of weird, but you're actually going to use multiplication to solve this problem. And a lot of teachers will teach this. And I'm going to write it here. And it's just an acronym for something that you can use when you solve these problems. It's called keep, change, flip. So what you're going to do is you're going to watch how this works. You're going to keep the fraction 1/3. You're going to change the math here. We're going to multiply. You're going to change the symbol. And then this is kind of the tricky part. The flip part actually represents a pretty important vocabulary word in years to come, and that is a vocabulary word called the reciprocal. A reciprocal is like a flip-flop of a fraction. And so what gets kids sometimes on this is when you divide and you have 1/3 divided by 4, really you're thinking about that 4 being called 4/1. And so I always tell my students, you want to turn it into a fraction, but you want it to have the same value. So if it's 4 and you wanted to write it as a fraction, you would write it 4/1, because technically 4 divided by 1, because that fraction bar is just a division symbol, is going to stay 4. So if it's keep, change, flip, the flip part would actually be you're flipping the numerator and denominator. So your problem's going to end up being 1/3 times 1/4. And this is really easy math. All you're going to do is you're just going to multiply across. Your numerators are going to stay, your numerators are going to be multiplied. 1 times 1 is 1. 3 times 4 is going to give you 12. And then now that matches that picture because we already had talked about this. We're going to get 1/12 as an answer, but now I can see it with an algorithm. So it's kind of different. It's new. It's just something that you got to practice. Practice makes perfect. All right, these next two examples, I'm just going to go through the math part. So just thinking math here. So here we go. We're going to take 1/6, and we're going to keep this in mind. Keep, change, flip. All right, we're going to keep the 1/6. We're going to change the division to multiplication, and we're going to flip-flop the 3 here. Well, in my problem, I could write it as 3/1, and it would be still 3. But if I write it now in my keep, change, flip, it's going to turn to 1/3. And so 1/6 times 1/3 is going to equal 1/18. It's really pretty easy now that you know the algorithm. Something else to keep in mind, and I think most teachers teach this, I know I do, and that is something to think about on these problems. When you start with a unit fraction, if your problem starts with a unit fraction, your answer is going to be a unit fraction. So you're going to start with a unit fraction, you're going to end with a unit fraction. So kind of think about that. All right, on this last example, let's look at it again. We're going to think again, keep, change, flip. We're going to think about keeping the 1/4. We're going to change the symbol to a multiplication symbol. And instead of it being 3/1, we'll change it to 1/3. We'll multiply across. 1 times 1 is 1. 4 times 3 is 12. We'll get that answer of 1/12. So, again, new, kind of weird looking, but the more you practice it, the more it will make sense.